Today is Module 2, Lesson 10. I can multiply decimal fractions with tenths by multi-digit whole numbers using place value understanding to record partial products. Be sure you mark your learning target in your journal. Let's begin. We're going to take these numbers 15 and 6/10 times 73 and estimate what it could be by rounding our numbers to their closest form. So 15.6 would round to 16, and 73 could round to 70, and this would get us pretty close. Because this is a multiple of 10, it makes it easier for us to mentally do the math here. So if we ignore our power of 10 for just a moment, we'll have 16 times 7. And 6 times 7 is 42. That 4 would carry over. 7 times 1 is 7, plus 4 is 11. I'll erase that little 4 so it doesn't confuse us. And then we'll go ahead and add in our power of 10. So we're estimating that our answer is going to be around 1,120 total. Now notice that doesn't have any tenths because we got rid of the tenths when we rounded to 16. But now we want to think about our 15 and 6/10 as only tenths. So we find that place value and we take every number to the left. So how many tenths are in 15 and 6/10? 156 tenths. And if we decompose our 156 tenths into expanded form along the length of our rectangle, we would have 156. So let's go ahead and divide our rectangle out to show 156 tenths. Now, for the width of our rectangle, we want to take our 73 whole units. So we'll put that in expanded form, 70 and 3/1. I'm actually going to redraw that line there because I want to show that 3 is not taking up quite as much of my rectangle. And now I want to go ahead and use this as an area model to help me organize my information. So 70 times 100, 7 times 1 is 7, and I have 3 powers of 10. 7 times 5 is 35, and I have 2 powers of 10. 7 times 6 is 42, and I have 1 power of 10. Now I have 315 and 1 power of 10, and 18. I'm going to add all these amounts up, and that should get me somewhere close to my complete answer of 15 and 6/10 times 73. And remember that our unit here is tenths, so then my answer will have to be in tenths as well. So I'll have 7,000 plus 3,500 plus 420 plus 300 plus 150 plus 18. And I do want to make sure that I'm very neat and organized with my figures because I'm going to be adding those columns up. So I'll have 8, 2 and 5 is 7, plus 1 is 8, 5 and 4 is 9, plus 3 is 12, plus 1 is 13, 7 plus 3 is 10, plus 1 is 11. And remember, this is 11,388 tenths, so I'll have to put my decimal right there so I have one number behind the decimal in the tenths. And notice that it's 1,138 and 8 tenths, and our estimation was about 1,120. So that's only 18 away with 8 tenths as well. So that's pretty close. Now let's take a look at this through standard algorithm. And I'm going to need to make some room here, so I am going to get rid of my work here, but I'll leave the answer at the bottom and I'll change colors so that we can tell the difference. So now I'm going to have my 15 and 6/10 times 73. And I'm also going to change colors here to show the different values so that whenever I am adding them later, you'll be able to tell a difference. Let's make that red. All right, so let's start with the 3. Right here in our ones position, 3 times 6 is 18. 3 times 5 is 15, plus 1 is 16. 3 times 1 is 3, plus 1 is 4. And now I'm moving on to this 7. So since the 7 is in the tens place, I will have 0 ones. Seven times 6 is 42. 7 times 5 is 35, plus 4 is 39. 7 times 1 is 7, plus 3 is 10. And I'm going to add these up. Now remember, this one is separate, so I don't want to get them confused. 8 plus 0 is 8. 6 plus 2 is 8. 4 plus 9 is 13. 1 and 1. And then remember, my factor was in tenths, so my answer should be in tenths. And since they're right here next to each other, you can see that they are exactly the same, 1,138 and 8/10. So how did this compare with what we've estimated? We estimated it would be 1,120, came out to be 1,138 and 8/10. That's pretty close. That got us within about 18. So that got us really, really close. So we know that our product is reasonable and we have added correctly. Our standard algorithm proved that we multiply correctly, and our estimation supports that claim as well. We can move on. These problems are asking us to answer in standard algorithm, and they set it up for us. 4 and 2/10 times 34. They do want us to estimate first, so we'll round that 4 and 2/10 to 4. 34, let's just leave it at 34 since we have such a small number. And we can do 4 times 4 is 16, 4 times 3 is 12, plus 1 is 13. So we know our answer should be around 136. And first thing we do is put our unit form. So we're looking at 42/10, and we'll multiply. So I'll represent purple as my first number here, and I'll do red for my second number there, my tens, just so that we can see the difference there. So 4 times 2 is 8. 4 times 4 is 16. I went ahead and wrote the 1 just because I knew there was nothing else there, and 1 plus 0 is 1. Now I'll take a look at that 3 in the tens place. I'm not going to have any 1s because I'm starting with the tens. So 3 times 2 is 6. 3 times 4 is 12. Again, I can just go ahead and write that 1 there because I know there's nothing else to add to it. And when I add those up, 8. 6 and 6 is 12. 2 plus 2 is 4. 1 plus 0 is 1. Now remember that our unit form was tenths, so our answer should have a tenths. It's the one number behind the decimal. So my final answer is 142 and 8/10. And 142, 136. Those are pretty close. That's a reasonable distance. Let's take a look at B. 65 times 5 and 8/10. So if we leave that 65 the same, and we'll round that up to 6, we can go ahead and figure this one out. 6 times 5 is 30. We'll carry over that 3. 6 times 6 is 36, plus 3, 39. So we're looking at a number around 390. Again, we're going to make our unit form, so we're using tenths. Again, I'll use purple for the 1s, and I'll use red for the 10s, just so we can see the difference there when we're adding. So 5 times 8 is 40. 5 times 5 is 25, plus 4 is 29. And now I'm moving on to my tens digit. I'll have 0 ones. 6 times 8 is 48. 5 times 6 is 30. cross those out because I don't need them anymore. And then I'll add those values. 0, 17, 3, and 3. Now remember, we're in tenths, so my final answer would be 337 and 0 tenths, or just 337. And my answer up here was in the 300s, so I am reasonable here. Let's go ahead and solve these using standard algorithm. And notice that I did put my answer in standard form because my directions told me to. So 3.3 times 16. And we'll start with that first digit. I'll make that one purple. So 6 times 3 is 18. 6 times 3 is 18, plus 1 would be 19. And now I'm ready to move on to my tens. I have 0 ones. 1 times 3 is 3. 1 times 3 is 3. And I'll add them together. 8, 12, 5. Now, remember that these are in tenths. So that would be 52 and 8 tenths. So let's take a look at the problem of the day. Rachel runs 3.2 miles each weekday and 1.5 miles or 1 5/10 miles on the weekends. How many miles will she have run in 6 weeks? So weekdays, we know that that's Monday through Friday, so that would be 3 2/10 miles times 5 days. And there's 7 days in a week, so I'm going to need 2 more days. That would be our weekend. And that's 1.5 miles, or 1 5/10 miles, times those 2 days. And that would give me all 7 days of the week. But they don't want to just know 1 week. They want to know 6 weeks. So we would take the sum of all these and multiply them times 6. Now, this is an expression we can handle. Let's go ahead and take our first multiplication. 32 tenths times 5. Oh, sorry about that. 5 times 2 is 10. 3 times 5 is 15. Plus 1 is 16. And our answer does need to be in tenths, so that would be 16 as that value. Then we have 1.5, or 15 tenths times 2. 2 times 5 is 10. 2 times 2 is 1, plus 1. So then that would be 30 tenths, or that would be 3 total. And then we're going to take the sum of those and multiply it times 6. So now we have 16 plus 3 is 19. So in 1 week, she goes 19 miles. In 6 weeks, how much would she go? How much would she run? Excuse me. So 19 times 6. 6 times 9 is 54. 6 times 1 is 6, plus 5 is 11. So in 6 weeks, she would run 114 miles. If she was keeping that same pace the whole time. And I want to go ahead and write that or type that for you. So I'm going to go ahead and type it very quickly and pause the video so it's going to pop up on your screen in just a second. All right, so I didn't want to have to make you watch me type the whole thing. So you can see here, in 1 week, Rachel runs 19 miles. In 6 weeks, Rachel runs 114 miles. So now it's your turn to independently work on your problem set. Make sure you're asking questions. If you need to, rewind the video, watch the steps, and make sure that you ask for help if you're struggling, because we don't want to leave today unsure. Good luck.